Hi Bobcats, this is Miss Lee, and today's video lesson is on prime factorization. Please make sure that you're taking good notes as you watch the video. Okay, prime number. Prime number has only two factors, one and itself. Excuse me. Okay, so look at 5. Remember, factors are numbers that you can multiply together to make a number. So think about what numbers can you multiply together to make 5. And that would be 1 times 5 or 5 times 1. Okay, there are no other factors, no other numbers you can multiply together to make 5. So 5 is considered a prime number. 17 is also prime because you can only multiply 1 times 17 to make 17. The same thing for 23, 1 times 23. There are no other numbers you can multiply together to make 23. So a number that is prime only has the factors 1 and itself, no other factors. So the opposite of that, well, let's talk about prime again. 2. 2 is prime. 2 is the only even number that is prime. A lot of you think that prime numbers are odd numbers, and that is false because there are odd numbers that have multiple factors, okay? But 2 is the only even number because we know that all even numbers are divisible by 2, right? Okay, but 2, the only numbers you can multiply together to make 2 is 1 times 2. So 2 is the only even number that is prime. Then the opposite of prime would be composite. A composite number has multiple factors. Think about 12. I know I can multiply 1 times 12 to make 12. And if I go up, think of other factors. I can do 2 times 6. That will give me 12. I can do 3 times 4. That will give me 12. 4 times 3 is the same as 3 times 4, so we're not going to list that again. But if you look, there are multiple factors. It's not just 1 times 12. Therefore, this is a composite number because there are several factors. Think about 15. 15 is an odd number, but it is not prime. Yes, 1 times 15 will give you 15, but you can also multiply 3 times 5 to make 15. Because there are multiple factors, it is not a prime number. 24, same thing. 1 times 24 will give you 24. You could also multiply 2 times 12. You can multiply 3 times 8. You can multiply 4 times 6. There are multiple factors that will give you 24, so therefore it is a composite number. So pause the video, come down here to the practice, and identify each number as either prime or composite, then come back and check your answer. Okay, 35 is composite, 42 is composite, 29 is prime, 19 is also prime, and 130 is composite. Okay, prime factorization is the breaking down of a composite number to all prime factors using a factor tree. Okay, so example here, we're starting with the number 20. This is our number. It is a composite number. It has more than just 1 times 20 as its factors, so it has multiple factors. We want to take this composite number and we're going to break it down to where we have all prime numbers. Okay, so the first thing you do is you start by choosing two factors that give you 20. You're not going to choose 1 times 20 because you're still left with 20. But you could do 2 times 10, which is what is done here, or you could also do 4 times 5. So looking at the 2 times 10, we draw little branches from the 20 to show one branch for each factor. So we're going to do 2 times 10. I like putting the multiplication sign here. 2 is a prime number. Remember, 2 is the only even number that's prime. Once you get a prime number, you circle it. So we're done with this branch. 10 is not prime. Okay, it is composite, so we need to get two factors that equal 10. Well, 2 times 5 will give us 10. So we draw 2 more branches, one branch to go to the 2. The 2 we just said was prime, you circle it. 5 is also prime, you circle it. So now at the end of each branch, we have a circled prime number. So we're done with our prime factorization. And now we're going to write our circled prime numbers as repeated multiplication. And when you write it, you want to put it in numerical order from least to greatest. So the smallest prime circled prime number is a 2. and there are 2 of them, so we're going to put 2 times 2. Then the next circled prime number is a 5, and there's only one 5. So the prime factorization is 2 times 2 times 5. Then we can rewrite that by putting the repeated multiplication, putting it in exponential form, writing it with exponents. So since there are repeated multiplication with the 2's, we're going to have a 2, it's repeated 2 times, so the exponent is a 2, times 5, and there's only one 5. So 2 squared times 5. Either way is correct. However, you should get in the habit of writing it in exponential form if you can. Okay, let's do another one. Here's 50. Come up with 2 factors. It doesn't matter which 2 factors you choose as long as the 2 that you multiply together give you 50. You could do 2 times 25. You could do 5 times 10. I'm going to do 5 times 10. So at the end of first branch, I put a 5 times, and the second branch, I'll put a 10. My 5 is prime, so I'm going to circle it. Move on to my next branch. Is 10 prime? No, it's not. So let's break it down, put 2 more branches. 10, 2 times 5. 2 is prime, we circle it, and we just said that 5 is also prime. Now at the end of each of our branch, we have a circled prime number, and we can rewrite it. Least to greatest, I have 1, 2, and I have 2 5s. So it's 2 times 5 times 5. Write it using exponents. There's only 1 2, so it stays a 2, times, and we have 2 5s. So it would be 5 squared. So 2 times 5 squared is the prime factorization. So go ahead, pause the video, and write the prime factorization for 36 using the factor tree. Then come back and check your answer. Okay, did you get 2 squared times 3 squared? If you did, great job. So if you're not, check out my example. The factors I used for 36 were 3 times 12. You could have used 6 times 6. You could have used 2 times 18. You could have used 4 times 9. Any of those factors will give you 36. And although your tree might look different than mine, you will end up with the same prime factorization. Okay, a couple more examples and then we will be done. Which of the following expressions shows the prime factorization of 750? We want to know which one of these equals 750. So you could go and you could multiply all of them together like we did. We showed you with the exponents, right? But before you do that, look at your answer choices. The clue word here is prime factorization. That means all of the numbers have to be prime. If you look at example A, is 10 a prime number? No, it is not. Therefore, A cannot be our answer. Look at B. Are all of the factors prime? Yes, they are. So B is a possibility. What about C? Are all of the numbers prime? No, 6 is not. Therefore, C cannot be your answer. And what about D? Are they all prime? No, 75 is not prime. Therefore, D cannot be your answer. And the only answer choice left is going to be B. Pause the video. Find the prime factorization of 280. Come back and see if your answer is correct. Okay, the correct answer is B as in boy. Once you go through each answer choice, you can eliminate choices by getting rid of those that doesn't show prime factors. Because that's your clue word. Okay, good job.